Hi folks, so this is question 6. So it's an arithmetic sequence, so you've got -5, this k number in the middle that we don't know yet, and then 1. So with an arithmetic sequence they have to go up by the same amount each time. So if we have -5, k, 1, so the jump from -5 to k has to be the same jump as to 1. So if you think about it, what's the difference between -5 and 1 is 6, so therefore there has to be kind of 3 in the middle. So if you look on a number line, the k number has to be 3 jumps to the right from -5, so -4, -3, -2, so it has to be -2, so k has to be -2. So that's the answer. And then if you think about it again, so think about what they're jumping. So -5 to -2 they're jumping 3, and then from -2 to 1 it's jumping 3 as well. So that has to be the way it is for an arithmetic sequence. They have to jump by the same amount. Yeah, so common difference is 3. So that's basically it. That's all you need to show. The second part, so find the 10th term in the sequence. So your first 3 terms now are -5, -2, and 1. Okay, so that's the first term, second term, third term. So the easiest way to probably do this is just to keep going. 4, 5, 6, 7, 8, 9, 10, and you're just going to keep going up in threes. So next one will be 1 plus 3 is 4, plus the other 3 is 7, 10, 13, 16, 19, and 22. So 22 is our answer here for this. That's the 10th term. The way they might kind of want you to do it is to find the nth term. So if you find t to the n, so t to the n is found by the difference between the terms, that's the common difference, which is 3, times n plus the 0 term. So 0 term is the one that comes before the first term. So here it would have to be -8. So -8 would come before -5. So 3n minus 8. So that's t to the n. And then if you sub in 10 instead of n, so we're trying to find t10. So 10th term, that's 3 times 10 minus 8. So 3 times 10 is 30, take away 8 is 22. So I found it that way as well. That's using the n term. That's probably the way that you really should do it. But 10th term, if you just count on until you get the 10th term, it does the same thing. Right, find which term in the sequence has a value of 247. Right, so what you could do, okay, 22 is that's the 10th term. That's the 10th term. So what you could do is you could keep adding on 3. So then you have 25, and then you have 28, and then you have 31, and then you have 34, and so on. So you keep going until you get to 247. So obviously that's going to take a long time. I'd say that'll probably take, you know, between 5 and 10 minutes in an exam, depending on how quick you can go, because you need to keep track of which term is which as well. So 11th term, 12th term, 13th term, 14th term. Okay, but that will give you the answer if you do it that way. If you're stuck, again, the proper way is to use t to the n. So that's the nth term. So t to the n there is 3n minus 8. So we want to know what value of n would that all be equal to 247. So what value of n would that be equal to 247? So we get an equation there with just n in it. So if you bring the -8 across to the other side, it becomes a +8. So 3n equals 247 plus 8 would be 255. And then it's just dividing into 3. And that will be 85. So 255 divided by 3 is 85. So It's the 85th term, so 85th term. That's our answer. So if you had kept going up there, along there like that, it'll be the 85th one. That will be 247. So that's that. Right, so last part then. So the first three terms of a different arithmetic sequence are 4, 9, 14. So 4, 9, 14. So there's a formula for this then for sum of, okay, so for the sum of n, so s of n, this is in the log tables, I'm pretty sure. So it's n over 2 and then 2a plus n minus 1 d. And it's just full fitted into this formula. What you could do as well is you could figure out what all the 50 terms are. So the next one there would be, you could do it on the calculator probably quick enough actually. You could just put in, so 4 plus 9 plus 14, and then the next one would be 19, and then the next one would be 24, and just keep adding them until you have 50 of them. Until you have the first 50 terms, and that'll be the answer because it's just the sum of the first 50 terms. But this formula makes it a lot easier. So S of 50. So A will be, when we're filling them in then, A is the first term, which is 4 in this case. D is the common difference. So there's 5 between the numbers this time. They go up in 5s. And then n in this case will be 50 because we want the 50th term. So it's 50 over 2, and then 2 times 4 plus and n minus 1, so that would be 50 minus 1, so that's just going to be 49. And we must multiply that by d, by the difference, which is 5 here. And then you can go straight to the calculator then if you want. So it should give you 6325. So 6,325. So that would be, if we found out the first 50 terms of that sequence and added them all together, that's what it would give you. So that formula calculates it really quickly, so it makes it easy. So that's it. That's all you have to do for that question.